Individualized quality control is far from a new idea. It has been recommended since at least 1989 when Dr. Westcard published QC selection grids. This is a modification in a QC strategy table that I published in the year 2000-2001. Back here, we were selecting the QC rule, single rule, or multi-rule, and adding QC chart frequency, increasing the control frequency, and initiating corrective action, individualizing the quality control based on how good is your method, how far can it move before you're in trouble. We measured critical systematic error every single month for every single QC sample, 5 disciplines across 6 hospitals. This is sodium. Remember, sodium we talked about runs a very low margin for error or critical systematic error. It went as high as 5 down to 0 at the lower level with a mean of 119, and we saw similar shifts at the mean of 142. There were critical systematic errors of basically 0 to almost 5. When that critical systematic error changed, when you came closer to your allowable error limit, we would tighten up the QC rules. Remember the difference that it made in the sodiums? AST, a different but somewhat similar story. High margins for error or critical systematic error in the realm of 25 to 30 standard deviations that you can shift before you're in trouble. However, with this reagent lot, that dropped down to almost 0. So when that reagent lot was in place, we used tighter quality control to make sure it didn't slip over this low end. Then you'd loosen off the QC, and with this reagent lot, it came a little lower again. But there's no magic 1.5 SD in anywhere here. I don't know if other studies have been done. What we did see is that critical systematic error varies over time for all tests in all labs, and that it's different between control levels. Control level 1, control level 2 did not have exactly the same pattern. If you're choosing QC rules based on critical systematic error, and it's different from time to time and test to test and control to control, I can't see how it makes sense to even think you could use the same QC rule for everything. As a matter of fact, I looked here at just the glucose in this study and separated it out with positive bias to the right, positive bias on level 2 at the top. So the upper quadrant, the controls both have a positive bias. In the lower quadrant, the controls both have a negative bias, but in the upper left and lower right, one is positive and one is negative. Seeing the bias patterns like this and the differences in critical systematic error, we found it worked much better to choose an individual QC process for each level of control.